Hello, I would like to welcome you to the Kentucky Valley Educational Co-op's The Holler. Today we are going to talk about students with learning disabilities in mathematics part 2. Students with disabilities have unique needs that are displayed in a number of characteristics that affect their mathematical experiences. Characteristics that I will discuss during this video are translating information into math, equations, and expressions, poor reasoning skills, defects in the areas of mathematical skills and computation skills, and also solving multi-step equations. First, we're going to talk about the difficulty in translating information into mathematical equations and expressions. Now, with difficulty in translating information, we find that there are errors in manipulation, conceptual, implementation. They have trouble between graphs and tables and understanding and translating that information. Now we're going to use some graphic organizers. We're going to talk about self-verbalization. We're going to also talk about the 3 reads and chunking information, and of course the CSA. Students with disabilities are hampered by the language aspect of mathematics and terminology. They have difficulty with following along with word problems and determining the steps needed to create an expression or an equation. Younger students may not be able to explain what that information is or what was read to them is even asking. They may have trouble seeing in their mind how the pieces fit together or only get hung up on a part or maybe even the last part of the section of the question. They may only get hung up on a part that catches their interest. Some things to help is that we need to teach students to chunk information. Draw the direction for the problem so we can have them to draw the information in the problem. Model what is asked, and then frequently ask students to tell what they think the problem is about. Have the students to explain the problem to a partner. Teach that student to self-verbalize the story or the sequence of the events. And then slow down the delivery or break up the problem. 3 reads for problems is great. First, they read a problem for basically the information that about what the problem is asking. And then second, they start to read for greater details. So they start thinking about what it's actually asking. And third, they read it again to answer the problem. Graphic organizers are a great help for our students who have trouble with translating information. Another thing that research has shown is that students generally who are able to verbalize or describe attributes and characteristics in graphs, tables, and functions are more successful. So we want our students to be successful. And sometimes we have to work backwards in the problem that we have, and they will need storytelling about the problem. So let's have them to do some of these activities when they're working through these problems. They may even use models when telling a problem. Creating a comic strip to the problem can help with some students. And then construction is action of generating new parts that are not given. And then also, these should always differ in the complexity and the difficulty. So start with easier and move up. You may have to move back a couple of times when they're doing these. So think about that when you're working with our students with disabilities. Our next thing is poor reasoning skills. Now, they're not able to reflect on the solutions, and they don't know if it really makes sense. So if they have poor reasoning skills, they may not be able to tell you if that makes sense. Now, how can you help? First of all, let's ask them why. Why did you come with that information? See what they're thinking. Have students work together. So if you have a student who's a little bit stronger so they can do that talking about it, have them to walk through and do a self-talk. Now remember, you have to explicitly teach self-talk to the student before they're able to do this. Determine how a student attacks a problem. What is their approach to that problem? And then what is their understanding of the problem and what it's asking? What pieces are they missing? And then I always model these through math talks. It's great to always help a student when you're doing that. Reasoning is an ability to think logically and analytically. Analytic thinking is the ability to see things visually in their mind. Many of our students don't have this, and this is why we recommend the CSA model for our students. If you think about it, they are not able to take concrete and even move it to semi-concrete, so they're not going to be able to put that image in their mind. That child is able to think step by step and break down a complex problem. Many of our kids can't see multiple step problems, so they need help with that. There is a difference between analytical and critical thinking. Analytical is the breaking down of information, and critical involves taking outside knowledge to evaluate the information. Students with difficulty reasoning do not see patterns or make inference. They are not able to see elements in the problem. They may not pay attention to details that others see as obvious, and you may even see it as obvious and don't understand why they don't see it. Students can determine questions and their positions in every way and reject, verify, and test formulas, or to be able to formulate or draw a conclusion about a problem. Our students are not able to do that. So they don't always see the elements in these problems. They don't always see the patterns and those kind of things. So keep that in mind when you're working with these students, the amount of things that they will need. Now, mathematical and conceptual deficits. Our students have a lot of these. And students what they need for math is an understanding of number magnitudes, the relationship between the numbers, operations, and a link to basic number sense and to quantity. Many of our students do not have this. So what can we do to help them? Well, what the student may need is practice. They need deliberate, intentional practice. And that practice needs to have feedback that is critical, and that feedback needs to be immediate so that they can correct the changes and they're not practicing wrong. Because when a child practices something and they've done it several times and it's wrong, it's harder to go back and get them to do it correctly. What students may need: finger counting strategies. They may need verbal counting strategies. They may need decomposing strategies, and math, reasoning, and problem skills. Now, for those kids that have these defects, the concerns that they have trouble with data. They can't break that data down. And with determining things like how much, how fast, how frequently something happens, students have trouble with being precise. They have trouble with their guessing answers because they don't understand if those are wrong. They have trouble looking at the data, like I said, and making a determination. And most of all, they don't see patterns. They have trouble with estimating, especially in measurement. And then they can't see a scale of information like you would see on a graph or a chart. They don't understand that scale, that magnitude of the numbers that's happening. So for our students, keep all this in mind. And like I said, they need practice, but it needs to be deliberate, it needs to be intentional, and the feedback needs to be immediate for our students. And it needs to be critical, yet loving. Feedback should always be critical, yet loving. Now, our last one is multi-step problem solving. And our kids have deficiencies in this. Now, I want you to think about what that means. They are poor strategic learners. They have poor problem solving skills. They do not have the relationship between fluid reasoning and consecutive functioning. They have trouble in what they need to know in the problem. So if it's got extra information in that problem, they may use it too. They will need explicit instruction in applying appropriate strategies. They have to have that. You're going to have to go over that many, many times with them. And like I said, it needs to be explicit, it needs to be direct. And those strategies need to be taught to them and them understand why you're using that strategy in the problem. Strategic number counting, making sure that they have that. And then intentional practice, like I said, intentional, deliberate practice. And copy, cover, compare is a really good one. So you go through the problem, you read it a couple of times, Like I said, with the 3 reads, you may get your information, you organize it outside, and then maybe you do the problem, they do the problem, and you say, okay, let's look at them. What did you do during your problem? Oh, I see you have the same steps I have at first, but why did you use this information down here? Now, let's talk about that. And this gives them a chance to see it, and then, like I said, like it says, copy, kind of copy off of you how your steps went, or give them a worked example to begin with. Now, why did you change this information up here and use this information instead? Those kind of things will help a student to start to build that knowledge. So doing those kind of things with our students.